We're just sitting there, and the boat yeah. So basically, you can't roll for you. They would fly out on media. So you have your eyes closed.
Alright, there you go.
But then it hits it, and as you go down, you're just looking at a couple of points out of the yeah. Yeah. People said that they passed out on that. I don't know.
All right, guys. How was the trip yesterday? It was fun. Was it your first time going to King Cod, Daniel?
Yes.
How was it?
It was fun.
It was short.
Yeah.
It's fine. I know it's like what, 5 seconds? You close your eyes and it's done. 60 seconds? No, that's not 50 seconds. It's not 50 seconds. All right. So, for those of you guys who don't have a TI-84, come up here and grab one, please. I only have 3. Rest of you guys just use your computer calculator if you can. Okay. All right, so listen up, please. We are nearing towards the end of the topic for statistics, believe it or not. We only have one last full week next week, and then that's pretty much the last week of school officially. The week after that is, we have half day on Thursday, and we only get 3 days, Monday, Tuesday, Wednesday, but I really don't think no classes are going to be teaching you anything there. So for the upcoming, I'm not sure about the rest of the classes, but at least for this one, we're not going to be. For the projects that's coming up, everything that we've been talking about, which including up to the last one, I'm hoping that you guys are fluent with using the calculators to find out the correlation coefficient. Anything that gives you 2 different variables, like for example, like X and Y, like this, and I ask you to plot with the scatter plot, show me how you did that on your project, and the correlation coefficient, the best line of fit, all that good stuff. Today, what I wanted to go over are the basics of the statistics. You guys should already know what mean, median, and mode is at this point, and in addition to that range. We're going to go into much more detail of standard deviation and something called the empirical rule next week. Okay. How many of you guys are taking psych? Do you guys know standard deviations? Yep. So standard deviation, you guys know the general idea behind it. I don't know if you guys ever talked about the empirical rule, but in stats, that's the one thing that you guys all must remember for AP statistics and beyond. Okay. All right, so I know that do I have any freshmen in this class? I don't, right? Oh, right, Noah. I have freshmen for every single one of my classes. Guys, are we good? All right, cool. I just need the data from you, mean, median, mode, and range. But first, what I'm going to ask you guys to do for me, all those of you on Zoom, is to tell me your age via chat. So I'm going to open my chat up here and then see, how old is someone. Generally speaking, for age of sophomores or algebra 2 6th period, what do you guys think we should expect as like the center, like the mean, median? What do you think? 15 and a half, about-ish, right? I mean, most of you guys are 16, right? But just for the sake of actually getting the data from you, can I start from Andrew? And I'm just gonna go down this list right here. 16. All right, next. 15. Grace? Noah? 14. Max? Max? 15? Yep. And then 16? 16? 16? 16. Then Owen? 60? 15? 16. All right, so Jacob, Jack, Wyatt, and Katrina, Brooke. Well, I have 5 16s already. All right, so do I have more? Oh, where's the rest of you guys? Actually, vast majority of you guys are here today, right? So I have, oh yeah. So there's only like, yeah, Ron is probably the only one. Ron is 16. Okay. So now I have perfectly 20. I think I have 21, 22 students in this classroom, but I'm not sure. But anyway, so I have this 20 data. Can someone tell me what the mode is? I think that's the easiest one here. Kate, what's mode again? There you go. So 16 is the most occurring number. And range, does someone know what range is? Charlie?
Is it like 14 through 16 or like, actually, forget that. Calling someone else.
Okay, well, you have the right idea. It's 14 through 16, but then you just have to subtract the highest and the lowest.
Oh, so 2.
It's 2. So range is simply highest number minus the lowest number, and that's it. Okay, so that's the range of numbers. Median. Anyone know? Christian?
Is it median or mean where you add them all up and then divide it by how many there are?
That's the mean. That's the average. That's the mean. So what's the other thing?
Is that how much of the highest there is?
No, that's the mode. That's the mode. Yes, Eddie?
I think it's 16.
Median?
Yeah.
Okay, but how do you get that?
So basically you cross off like the first and last and you keep on going and then in the middle it's 16.
So you first have to chronologically order them, right? So I have 3 15s, and then the rest of them are 16s, but let's just copy and paste this like this, and you get the idea. But here I'm gonna cross out one from each end like this. That you keep on doing that until you get the center, which will be 16 right here. And no matter how I do it, the 16 is the most occurring number, but there's just too many 16s in here, so the median will be 16. Last one, mean, like Christian said, that is the average. You already know how to do the average. You're gonna sum them all up. You're gonna sum all the x values, and you're gonna divide by the number of the numbers in there. And there's total of 20 numbers here. Okay. All right, so I'm gonna still have this data, but what I'm gonna ask you guys to do is take out your calculator for me, please. And then we're gonna input this data one by one, and you're gonna have to do a lot of these for me today. The ages of sophomores, if we could go to our stat list, and we can edit the first column with these numbers. So let's do that, okay? So go here, and I'll do the calculator. And then we're gonna go to stat, we're gonna go edit. So let's type it away. 16, 15, 16, 14, and then 15. We're not gonna switch up to different columns. We're just gonna type everything into one single column like this. Okay. So it should say list 1, 21 once you're done. Because that just means that I've inputted 20 numbers in there. That just tells me that I've done everything right. Oh, my fault. There you go.
How many numbers should we have?
We should have 20 numbers in total, which means this one should show up as 21, like this.
Mr. Kim, the way you put the numbers in, you read across, right? The the table, like 16, 15, 16, 14, 15, right?
Raise your hand if you're having trouble with the list here. Okay. All right, so here's what I'm going to ask you to do next. Once you input all the data, today what we're going to talk about is something called histograms. If you guys are familiar with the standard deviations and the normal distribution curves, all of those stems from something called a histogram that measures something called a frequency of the data. So for this particular example, what we're going to do is we're going to go to stat plot once again, can you guys turn this first one on, which I'm hoping from the previous settings that you guys already had it on. But here's what I'm going to ask you to do to change to get to the histogram. Do you guys all see the third one in the list of type that looks like a little bar graph? Oh, so press second y is equal to. So plot one on. And then here, if you do, you good, Kate, now? Perfect. Okay, so the third one here, it says, it gives you a little bar graph. If you click on that, notice how it changes from X and Y list to just X list, because you don't need a second list because the Y value will be just measuring how frequent the number it is. Now, let's say if I press graph right away, I am not going to get the data that I want. And I still see a blue line across it. This is my default setting. So what I'm going to do is I'm going to go to my windows and let's change the settings up a little bit. Well, our age was anywhere between 14, I believe, to 16. I could make it a little bit, giving a little space. So I could say like 10 through 20 or something like that. But I just wanted to show you just those three values. And then for Y-min, can we please change this from 0 to 20? 20 being the highest number of students that this could be in this classroom. And then press graph. And then unfortunately, I'm not really getting the data that I want. So I'm going to change my windows, like I said before, from 10 to 20 instead. Let's change it to that. And this is what I should get. You got, so 10 to 20 is X-min and X-max. I'm going to leave this up here. Y-min is 0 to 20. You said you got the hurricane? There. Oh. Yep, that you got over here. Unnecessary graph. Invalid dimension that is in the window. So
Mr. Kim,
all right. Yes.
I'm also getting an error.
Okay.
I'm not having errors.
Check number of data points.
I have 20.
Oh, because you have two of those turned on. You want to turn one of them off?
I am.
So let's see if we turn this on. Well, that's good. Check the number of data points needed for the calculation. Oh. Okay, I don't see anything wrong with that. Alright, so that means something's wrong with your windows. 10, 20, that's 0 to 20. There you go. Yep. Alright, yep. Yep. Because your window setting is not correct. So let's go to Windows. And then go to that, go to edit. Go to that plot. Yeah, you have to and then click on the there you go.
Yeah.
Okay, Carly, you said you raise your hand?
Yeah.
Yeah. What's up?
Yeah.
So you gotta see that plot. Okay, you turned it on.
No, I connected it before I went.
So you gotta push this and this is not the data that
Oh, okay.
Yep.
He sees it, but then it is.
Ah, okay. And then window settings. I'm gonna just shoot these here for a little bit. Oh,
It's like they're all sold out.
you have everything from there. Look at all this stuff. You may have to look at this.
Oh, yes, sir.
You want to get rid of all of this. Then, now you have this.
I only played around with
Window.
it. Literally.
I'm gonna just, sorry. 10, 20, then
Okay, Mr. Kim, I put the new data in, now it's not, wait, how'd you get there, edit?
Yep, edit. Well, you go to stat and you edit the list. So you got all these numbers. The age is from this slide here. Okay. If you press graph, that's what you guys should see. So what you see here is that I only have 3 data that I could get. I have either 14, 15, or 16, or among 14, 15, and 16. Out of those 3, you can see that the 16 is the most occurring number because of the y value here. They have nothing to do, like there's no parameters for the y. It's just frequency. So the way that we interpret a histogram is how frequent is something happening. So for the age 16, I approximately have, I think, what, like 16 of you guys that are 16. So if I go back to this slide here, the measurement of histogram is a bar graph that measures frequency of the data. This is what I really want you guys to understand. Okay, so this is not a bar graph. The y-scale only represents frequency and nothing more. That's why they only ask you for the x variables, whatever they are, depending on that. They count how many of those that some values are bound to be repetitive. It could happen more than once. And it just measures how frequent that particular data is. Okay, so that's what a histogram here is going to be. So for the next part, and I think everyone just gets the idea of how to put the data in and get the histogram and all that stuff here. Let's just practice using the data. Okay, I know that this is going to be tedious, but on your calculators one more time. This is the age group, I think, for the data set of, I think, a particular, I don't know why it's missing a context, but I know that these were had to do with age. So judging from the numbers here, I guess it's like, I don't know, summer camp with, with you randomly sample some of the students there from anywhere between like 5th grade to maybe even the counselors too, because I see the one person with the age of 21. And then you try to make this as a distribution curve. You're trying to make this as, with the histograms and all that stuff here, okay? For those of you who missed out, onto the calculator, please. This is a lot of numbers that I want you guys to type in. So I'm going to write this down bigger for you so you guys can see from back there. Please type in on the list 2, or you can delete list 1, whichever you like. 10, 12, 13, 15, 13, and then you just keep on going on the list. Then I'll write it for you also here.
How many numbers should there be in each list?
There's only one list, right? The total number for this one, let me just give you a little head count here. So that should be 36 numbers. In one list, yes. $35 number. So for your histogram also, please try to change your windows as well, okay? Your window settings should be anywhere between like 10 to maybe 22. Or actually, don't make it 10. Try to make it like 8 from 22. You want to give it a little bit of space on the other end. Sorry, I'm also going to type this over. I'm going to zoom into here.
So that X min should be below 10 and X max should be above 21.
That's correct. Because if you don't do that, otherwise it's going to give you a line, but you want a bar. So you want to have just a little bit of data at the end. X min and X max, just something below 10 and something higher than 21 should be good.
Can you go back over a little bit?
Go over.
Or is that all the numbers right there?
These are all the numbers.
Got it.
Yep, these are the. They should be 36 numbers. Raise your hand if you're having trouble with this. Okay. Guys, after you put in all the data, I need you to be able to plot the histogram onto the graphing calculator here. If you guys were to use stat plot and if you turn this on, make sure that whatever the list that you have put it on there matches with the list that you have here. For me, I made the list 2 as a data distribution here. To recall any list, if you just go here and then on the X list, you go to second stat, you can click on any of the lists that you like, whichever one that you have put in the data into. So since I put in list number 2, that's where I'm going to be. And then if I press graph, there's my histogram. Of course, I changed the Windows settings up to accommodate for the fact that this is different from the sophomore or / freshman age. X min, X max, we change it. Y min and Y max, we also have to change it a little bit. And then there's my curve there, or there's my histogram there, okay? Make sure that you have this on your calculator at this point, okay? In a real world statistics, you want to get the data distribution to look something like this, okay? If without any bias with your sampling method, you should end up getting a data set that looks like something like this. We call this the normal distribution. If we were to draw a curve on top of, and we can kind of see like, you know, at the top of the histograms, we can see a lot of numbers are centered right down the middle. And of course, there's some discrepancies here onto the left and onto the right, but this is generally called a normal distribution curve. Let's say that I take all my Algebra 2 kids and I asked you guys, what'd you guys get on your last test? Okay. Or if, like, maybe not for my test because you guys do so phenomenally well, but let's say for some, like a SAT test, if you will, a standardized test. Generally speaking, we would say that a lot of students get somewhere in the middle, a lot of frequency happening at the middle, which is the average. Some students do really, really well. Those really extremely smart kids that gets 800 maybe for the math SATs or 1600 perfect score. Or there might be some students who do really poorly. But we tend to see this curve in much statistics that we take in the real world. But not all the time is it going to be like this. Okay. First of all, are we okay with drawing the histograms onto our calculators? Okay.
That's okay.
All right. So I'm going to show you another example.
You can hear me.
Okay.
Like,
And I know that so this was a data distribution that I wanted you guys to get. Notice again, the normal distribution curve that you guys get. And then we're going to go over some of the examples. I know that this sounds tedious, but I'm going to ask you guys to please just do this one more time for me. I have another data set that I want you to plug in. This is the ACT test scores that for this data distribution, just for the sake of the argument, I take a group of 36 students and I ask them, what'd you get on your ACT? This is their reported score, okay? So let's put this into our list one more time. I'm gonna rewrite this for you in a bigger font.
He was like, oh, you were there? I was like, yeah. We were staying behind center field most of the time.
There's 36.
They left.
Yep.
Jack, your speaker volume turned down.
My speaker volume is turned down. Hello, can you hear me?
Yeah. Hello.
Oh, they have questions, but I can't hear them. Can you guys, Jack? Yep. Are you there?
Yeah. Hello.
Okay. Hello. I can hear you now.
Oh, okay. I just have like a one question. I guess it's also on this one right here. I just like when you're putting it into the list, how you have to like split it up into two lists. Like
Yeah.
where is like the first row? Is that your one list and then the bottom is the other list?
No. Like for me, I just didn't feel like deleting them all. So I just kept the list 1, which was the age of all the sophomores that we did in the beginning of the class, right? And then for the list 2, that was the data that I had to put in for my previous slide. Now, the list 1 and list 2, they're 2 separate histograms that I drew. And on the list 3, I can type in 24, and then I can keep on going down this list. But there should be 36 numbers in total.
Okay, so you put all of them all in one list because I did that and I don't know what happened.
Yeah,
I
so
just did
after, right, so after that, if you want to make a stat plot with this, you see that where the X list is, right?
yeah.
All you got to do is change the X list to whatever you're talking about. So if I wanted to go back to talking about the ages of the sophomores, I can go to list 1, which were the ages of sophomores.
Oh, okay. That's what,
And so to get the list 1, I press second, and then I press stat. Then I can call whichever names that I want, whichever list that I want.
Okay, thank you. Let me do that now.
Yep. Oh, yeah, there we go. So, yeah, so second, 1, 2, 3, 4, 5, 6, right? That's where they were, yeah. So second, 2, that also changes it. So I'm going to leave it as second 3 because I want to use list number 3. And this is the most tedious part of this, where I have to kind of type away all of these numbers. But I'm assuming you guys all did it, and make sure you have the histogram with you. Okay. All right. So I think, Carly, you already have the histogram, right?
I did, yeah.
Yes. Can you share with us your Windows setting, please?
Yeah, I did 20 to 30, 37.
20 to 37 sounds good. And what about your Ymin and Ymax here?
I still have mine at 0 to 20.
0 to 20?
Yeah.
Okay.
I didn't change that.
Oh, from the previous one too, right? Okay. So, just to have a little bit of a higher graph, I'm just going to change it to 10. So it's a little bit bigger to see there. All right. So let's take a look at this data distribution. And can you guys all see, if I were to draw this normal distribution curve, okay, it will be a little bit more geared towards the left-hand side. Can you guys all see that? Okay. It's not really a perfectly well-rounded bell-shaped curve like what we had before. This is something where we can say, okay, so based on this study, we can say that a lot of people tended to get a little bit, on the lower end of the spectrum than on the higher end of the spectrum, or even in the middle. Okay. So when we get a data distribution that looks like this, there's a specific word that we associate with that I want you guys to write down. There are 3 instances. So they are here. The very first distribution that we have encountered with the age, that's something called a normal distribution. And this is the ideal shape that we want in the statistics world. However, in some cases, we can get something called skewed graphs, where we have something called a tail. This is called a tail of the graph. This is called the tail of the graph here, where it's kind of, we still have the data on towards the right-hand side, which is on here, but you can see that generally the center is somewhere to the left or somewhere to the right, not exactly at the center. And so the opposite side of that, where the center is, we're going to call that a tail. Okay. So while normal distribution is continuous, discrete distributions like the one above can have a normal shape. Distributions with other shapes are called skewed distributions. Okay. So they're not really evenly spread out, but they're still considered a distribution. Mass of distribution at the left and the tail to the right. So we call that a positively skewed distribution. We tend to say whichever direction is skewed to, wherever the tail is. So if the tail is on the right-hand side, we generally associate right-hand side with positive. So we say positively skewed, or we can say skewed to the right. That's what we say. And then for the other graph in which we haven't done, for the data distribution, we can say it's skewed to the left. Okay. So the ACT test scores that we just did on your graphing calculator, this is the graph that we will get. We have a positively skewed distribution. That's what we would say for the conclusion of this graph here. Okay. So for your homework, if I give you a data statistics like a table, and then I ask you to, of course, plot them and get the histogram, and I ask you, like, just by looking at the distribution, is it normally distributed or is it skewed distribution? Please be able to tell me how to be able to do that. The one that we just did here with the ACT, this is a test, the graph that you guys all have seen on your graphing calculator. We can see how the tail is on the right-hand side if I were to draw a little curve on top of it. So this is skewed to the right. That's what we would say for this one. Okay. All right, any questions about this? I'm going to talk to you guys briefly about how we can determine something called a standard deviation, and then we're going to call it a day. Of course, I'm going to end this lesson just a little bit earlier than
I have one question, Mr. Kim.
Yes, Jack?
So sorry, if you're going back to the one we just did in the calculator, how did you know the window settings? Like for the Y, I don't know. Mine, like, I guess there was really big, and like I just can't, like, the histogram thing just didn't look good.
Right. So here, to first determine your X min and X max, it really comes from the data, and you look for your highest and your lowest number. Okay. The highest number here you got was, I think, was 35. And the lowest possible number you can get from this list is 24. So when you make your windows, try to think of a number that's less than 24. So you can say, let's say 20. And so think of a number that's higher than 35. So you can say 40.
Yeah. So that's what I have for the X. It's just like the Y, I don't think I had right.
So for the Y, it's really vague because you're not going to sit there and just count each of these by numbers, like, like how many there are. But generally speaking, for this one, there's 36 numbers. And then if I were to count how many of these numbers there, by maximum, I could have 36 of the same numbers then, right?
Yeah.
But of course, that's not going to give you a really good graph. But at first, you might want to start off with just count how many numbers there are. So there's 36 numbers. So you can say from 0 to 36. And then that will give you a bar graph really, really, like, in teeny tiny size. So you might want to cut this down to maybe 10 just to make it a little bit more appropriate, or even 8 for that matter.
Okay, yeah, because I had 40 as the max, and then it was like it was like low to the thing, so I don't know if I should like change it. Okay, thank you.
At first, you check to see of like 40 if it works or not. Then if it doesn't work, then you want to cut it down to maybe like 10, 20 or whatever, and then you want to like appropriately measure the graph based on the settings that you get as a result.
Yeah, thank you very much.
Yep. All right. So again, any other questions you guys have? Okay, we're all good with that. All right. So with the last thing that we're going to be talking about today is something called a standard deviation. We're going to go into a little bit more detail of how to determine a standard deviation from a data set next week. Something called the empirical rule, in which I need all of you guys to be familiar with. And the rest of the week, we're just going to second half of next week, we're going to be really focusing on, how to determine the project. And it's a really good idea to start thinking about, going back to this thing. I gave you a data distribution of an ACT test scores. What I'm going to ask you to do is find some data statistics in your own world by yourselves. Okay. There were some of the things that I was associated. I think one of the students asked me about basketball. I just remember there was a lot of data and statistics with the basketball that if you're particularly interested in that you could do. And then you can find all of these different things with the skewed distribution, with the standard deviations and all this good stuff here. Okay. So first, let's start off with the definition. The standard deviation is a measurement of spread this is really the main thing that I want you guys to take away. How spread out is the data? So the mean is always centered at the middle of the standard of the distribution curve. And we're just simply measuring how spread out the data is. That's what a standard deviation is all about. If you have a low standard deviation, it means that the numbers they don't really vary much, okay? They're very close to being the average. A very high standard deviation means that the numbers are really, really spread out, okay? That's what I want you to take away from this one. I'm going to go to my stat plot one more time, and then I'm going to do list one. The very first thing that we did with, let's say, 13 and then 17. And I got to make this into a 20. Oh, 0. All right, so there we go. All right, so for the standard deviation, okay, imagine for a second, I think I better change this window setting as well. Okay, so something like this. Imagine for a second that if I go back to the age distribution graph that we had before, okay, let's say I was trying to measure what we call a spread, how spread out this data is. Well, we only get 3 data sets, which is 14 and 15 and 16-year-olds from the data set that I get. So just by looking at the context, if I were to measure something called a standard deviation, what I would say is that this is going to give me a low standard deviation because there's not that much variances with the actual numbers. Like 14, 15, and 16, you only get 1 out of these 3 options. If I were to give you guys a new test or a survey or observational study for that matter, let's say I ask you guys for the height. I'm going to go the same thing, and I'm going to start from Chris right here, and then I'm going to ask you guys for the height in inches, please. So if you're like, let's say 5'6", please convert that into 66 inches. Every 1 foot is 12 inches, by the way, guys, okay? Before you tell me the numbers, can someone tell me what's to be expected of the standard deviation number? Comparing your age, standard deviation versus your height.
There's going to be a lot more variations with it.
That's right. With the height, I can get anywhere between, I don't know, like 64 to 70 inches. If you're talking about age, it's 14 through 16 only, so there's not that much various different numbers that I could get. So we can expect to have a higher standard deviation from this. Okay, so now let's actually get the data here. So Algebra 2 class, starting with Chris.
67 inches.
67, just round your answer to the nearest, inch, okay? Carly? 60. Owen? 73. James? 60. Oh, my fault. And for those of you on Zoom, could you guys also please convert your height into inches for me? And please tell me your height through chat. Okay. All right, and Kate? Yep. 63. Charlotte? 65. 67. 67.
71.
69. Okay, and then
At least I'm in the 60s.
Jack 65, Brooke, Katrina, Wyatt, and then Jacob. Okay, and how tall is Ronit? I know he's not here, but let's assume
How tall is Ron?
64.
Ron's about the same height as who?
Let's give Ron a 63. Ron is
67? I think about 67 is good.
Yeah, Ron's right.
67. All right, so last data set I promised. Let's put it on our table.
No, it's my favorite though. So.
Can you guys see from back there? You guys can see it? Okay, great.
Why do you guys' eyes look different? I don't get that one. This one's funny. See?
All right, so there should be 20 numbers, just like the one we did before. So you should say list 21. It should be blank from the 21st number, and I'm gonna try to draw the histogram. So we have anywhere between 55 to, I'd say, 75. Frequency, I can still go from 0 to 10. No, that's not showing at all. Oh, stat plot. I gotta turn this on. List. I went across. That one horizontally.
Oh my god.
I was trying to see the screen time.
Yeah, literally everyone was sleeping on the bus except for Jordan.
When did you guys get home?
He's just yelling.
With 5.
I get to school at 5?
Yeah.
Yeah.
Oh, okay.
Jordan was just yelling.
It was like the park was almost like not completely empty, but there weren't as many people as there.
How many time? What was the wait time for King to Call or Nitro?
Like 5 minutes.
5 minutes?
No, there was one was like we waited for a solid half hour.
Batman, and it was
Yeah.
like not even worth it.
Batman was half an hour for
It's
wait time?
literally none of them, you're never, see, like, here's the thing, you're online, yeah, let's say you're online for 20 minutes, and it's a 4-minute ride.
Everything else was some.
I'm never gonna like get off the roller coaster and be like, yeah, that line was so worth it, but this is actually insane, like, I don't know why it was that long, we waited, like, Nitro, we waited, James, what, like 5 minutes, and then we go to Batman right next to it, and it's crazy. Oh, I love Nitro,
Batman. Oh, did you guys see the construction for the new roller coasters?
Oh,
yeah, no, I saw the construction for the Jersey Devil.
The Jersey Devil one, yeah.
Yeah.
But you guys weren't able to get on that? It was not open? All right, guys, last thing I'm going to tell you guys before, we end the session. So this is a histogram for the height of Algebra 2 class. If I ever ask you what type of distribution it is, do not tell me that it's skewed, because if you're just focusing on the bars here, just look at where the center is and where the endpoints are. I know that there's a little bit of a gap space here, but this is, generally speaking, roughly normally distributed, and rightfully so. This is only about only about this class. If I go to my next door and then I ask the next set of students what their height is, we'll get more data set, and then it will generally tend to be a lot more better accurate measurement of a normal distribution curve. Okay, so with all that being said, could we all please go to stat, please?
Yo, who's 63?
I'm not sure who this was.
It's okay.
Okay. Anyways, guys, go to stat, please. Go to calc. The very first thing you see called one variable statistics, please press enter. For me, my list was 4, but yours probably was list 1. Wherever you have inputted that these numbers in, please make sure that your list correlates, or it's exactly the same as where you put it. And then press calculate. And then you get all this numbers in front of you. And I'm going to explain to you guys the important ones and disregard the non-important ones. Okay. Raise your hand if you can't get to this.
Can you show me one more time?
Sure, yeah. First, go to stat, go to calc, one variable stats. Make sure that your list is the same as where you input the data in. So mine was list 4, and then you press calculate. The ones I'm highlighting for you in red, these are really the important ones. The rest of them, these are the process of where they use to get the standard deviation. They're called variances. Variances is a measurement of how much apart from the mean to the actual data itself. A standard deviation, remember it's notated with a Greek symbol called sigma. That's that little sigma notation right there. So that's your standard deviation. So a couple things to note. Right now, all I need you to be able to do is use the one variable statistics and get the measurement of the standard deviation. The very first one with the extra little bar, that is called the mean. So you don't have to add them all up and divide by the number 20 to get the mean. They actually do that for you. The minimum number that I had was 60 inches. And then if I keep on going down this list, I get this maximum of 73. I believe that was you, Owen, right? Right. So here, yes. So again, if I go back here, if I ask you for standard deviations, please write this down. So this standard deviation was about 2.854. So please remember that. And then I'm going to show you guys something else. You don't have to copy this down. One variable statistics. Let me use the list one. The list one was your age. Okay, so now see the difference between that to this. For your age distribution graph, I have the same 20 number of students. My mean is about 15.5-ish. I know one of you guys said that, 15.75. But look at the standard deviation. It's really low. Compared to like 2.85, this is 0.53, which means my number is very, very small. And the number of distribution that it's happening, it's very low compared to the height. As Christian, I think Christian, you're the one who said, because there's more variances, right? Varieties of the numbers, therefore higher standard deviations. Okay. All right, so make sure you guys know how to use the stat button, getting the one variable statistics test. I think this is a good place to kind of press pause, and then we'll pick it up from where we left off for next week. For homework, I'm not going to give you a lot, just like 2 questions. I'm going to give you a data set. Just play around with the calculator and tell me what the standard deviation is. Tell me what type of distribution it's going to be. All right. And that's pretty much it for all I have for you guys right now. If you have any questions, just please let me know.
Mr. Kim, I have one last question.
Sure. Yes, Jack.
So talking about the standard deviation that you just were like going over.
Yep.
So we know that like for the other one, the height we had like 2.8 or something.
Yep.
And then for the age we have 0.5 like 4 or whatever.
Yep.
So does that mean like so like can you explain like what that means again? Like if it's lower, that means it's a lower deviation, or
Yeah, so the standard deviation, we talked about how a low standard deviation means that the most numbers are close to the average. What that means is there's less variety, less distribution. So like you get a lot of these numbers, like centered at like one particular location, like this. Okay. Whereas for the higher standard deviation, you have a bunch of these numbers like really well spread out. It's really widely spread.
okay, so lower the number, the lower the standard deviation, the higher the number, the higher standard deviation.
Not the number, lower the varieties of numbers, if you know what I'm saying.
Yeah, yeah, but like when you look at like the number that like on the calculator, like 0.5, and like
Yep.
you kind of that's like it's a lower standard deviation.
Well,
than,
compared to 2.85.
yeah.
Yeah, compared to 2.85, this is definitely going to be a low standard deviation.
Okay, thank you.
Yep.
All right, we can leave, right?
Yes. For those of you on Zoom, if you have everything down and if you don't have any questions, you may leave up Zoom. And have a great weekend, and I'll see you guys next week.
Have a great weekend.
Yep.
Thank you.
Mr. Kim,
Yes.
can you just look at my Schoology message so my grade can be fixed?
Yes.
Thank you.
Well, there's actual character in the pattern, but it takes place very strongly.
That was an actual spelling bee.
I know, everybody knows. It's a play. It's called spelling.
I had no idea we were even running a play.
I would, no, there's only seniors and junior boys, so it's like a really small cast. They were going to, because like the only boys like were going, but they actually. It didn't show it. I couldn't kill it.
Yes.
No, but I need to look at it. Why knows my part too well. Like, I'm helping. You're right. Dude, I could. No, but boy, I'm gonna get what anyway, because
Guys, we have until 150. I know we're supposed to get at 152. I'll let you out at 150 though. We have 6 minutes left.
Mr. Kim, is that one of those shirts that like, who doesn't love walking? Put like the thing over it, the bike will like.
Am I gonna go on the track?
There's a shirt like that.
I think that's what that one is.
Put what on here?
If there's a, like a coordinating sheet that is so hard to explain, that has lines on it. And if you run it up and down, it will look like a bike.
Oh, so it's like an eye illusion.
Yeah.
Oh no, it's not like
I
that.
swear, he had the shirt too, or else I might be like, just doing it. Because one of those like Under Armour shirts, be like, what if this worn, it would be purple. I have that, yeah. It was like a teal shirt, and then if you wore it, it'd be purple, because of like, if you.
I had two of those. One bird, I got like soaking wet.
No, this was just like if it was hot, it would turn purple. If it was cold, it was like white. I don't know why, I just remember that. That's so funny. You were
Would you like to see it, Carol? Whoa. What a cluster is soft.